Today we will discuss di-π-methane rearrangement. For di-π-methane rearrangement, we required the minimum reactant and the condition is H nu condition, photochemical condition. Also we required for this carbon should be sp3 hybridized and there two substitutor present. This is the minimum condition required. Mechanism of this reaction is first these two double bond will be break, turned into radicals. Then these two radical from a bond. Here these two radical is same. Here no driving force present for stabilizations. So these two bonds, here any one of bonds will be break. And turns into the radical. And from these two radical from a bond. And these two radical also formed a double bond. This is the basic mechanism of di-π-methane rearrangement. Here if the reactant, here a pH present, phenyl group present, then this is a stable radical, so this side bond cannot be break. The opposite side bond will be break and turns into a radical. And from these two radical formed a bond and these two formed a bond. So the product is this. This is the basic mechanism of di-π-methane rearrangement. Now if the reactant, this here two hydrogen present, then in H nu condition also these two double bonds breaks into the radical. But here 1,2 hydrogen shift happen. Here this is a allylic radical, this is the more stable radical, that's why 1,2 shift happened. And these two radicals from a bond this is the product. Let's see a example. Let's see this example. Here two double bond present, sp3 carbon present and two substituted also present. So the di-π rearrangement occur. These two double bond breaks and turns into radical, here you can see this is a allylic radical, this is also a allylic radical, so this is a stable radical. These two radicals forms a bond, so both sides are same, so one of the bond will breaks and turns into radicals. This is the major product. Let's see this example. Here sp3 carbon is present and there are no substitute present, only one present. So here what happened, let's see. If this double bond will break into radical, then we here you can say 1 to hydrogen will be shift. If 1 to hydrogen will shift, the product is this, but you say that here allylic radical present, so this is stable, but this is a bridgehead carbon and here radical cannot be stable, so here 1 to hydrogen shift cannot happen. Here Di-π rearrangement will occur, and there these two radical is same, so one of the bond will break and the product is this is the ultimate product. Let's see the last example, which is came into the 2021 GATE exam. Here two double bond break. You can see here OMe group present, so their plus M effect is high than pH, so this radical is more stable. So this is more stable, that's why this bond will be breaks and turns into radical. And this radical bond, and this is also from bond, and the major product is this is the major product.